So let's look and see what acids do in water. Now, if you remember from the last chapter, we were talking about polarity, and this is an acid right here. And you'll notice that in this bond, we have a polar bond, and it's a very, very polar bond, actually. And then if you look here, again, we have a polar bond there, and then overall, the molecule has a lot of polarity with it also. So acids are going to be polar. Now, if you remember, water is also polar, like this. And it's got this overall dipole. So whenever something has dipole, it's called polar. So it's polar. So if an acid is polar and a water is polar, that means that they will dissolve into each other. Now, some acids get this, if they get big enough on one side with a lot of C's and H's, then sometimes that can affect how well they dissolve, but you would have to have a lot of C's and H's to affect that. So since they dissolve in each other, we use this AQ term. So this term tells us that something dissolves in water. It does not necessarily mean that it breaks apart into two parts. Now, in the salts, when a salt dissolves in water, it does so by breaking apart into those positive and the negative ions. But this just implies the dissolving, and you have to know that it's going to break apart into the two ions. So for acids, what acids do is that they're, for the most part, acids do not break apart in water. There's this stuff called hydrogen bonding. There's a lot of stuff that's going on when acids are going in water. You learn a lot about acids in Gen Chem 2. But for now, all we're going to tell you is that there are some acids that will go apart in water and the rest don't. So the ones that will break completely in water, we have HCl, HBr, HI, HNO3, HClO4, and H2SO4. Those are the only ones that will break apart completely in water. Everything else that has an H in front, you're going to put it together. So like CH3COOH. You will also see acids that have an OOH look to them. That's the other way. So they either have like a H or they have the COOH look to them, which I know is confusing because it kind of looks like an OH. But again, this also means acid. And so this has an H in it. And that H, it doesn't look like any of those. So this thing will stay stuck together in water. HF is another example. Again, it's none of those in the list, and so it stays stuck together, even though it will dissolve in water. Another thing I was going to show you, just a quick comment back to this one. Sometimes this is acetate. This can also be written as C2H3O2 minus. So you'll see it both ways. That's the same thing. And if it has an H on it, sometimes the H will be put in front, sometimes at the end, and I know that's not nice. But most of the time, the H goes on the front for everything that you're going to see in general chemistry. So to make this easier, if you go back up to your chart, right over here, we actually have an acid section to the chart. And you can just know, as a little reminder, you're going to use AQ. All of them use AQ, but it goes into this insoluble section, or I guess it'd be better to say it falls under the do not dissociate section. So everything here, they don't break apart. But then these ones over here are the acids that break apart. So these are the matches to the list I gave right down here. The list that's circled. So my highlighted section, those are the negative parts of the list that's circled. So if you just want like a quick answer as to what the acid's going to do, that's what you can do. You can just look on this chart, and then if it's got those negative parts right over in here, then it will break apart.